So if you look on page 69 and 70, there's 5 equations. So what you're going to do is actually take out a piece of paper right now, and like you're learning to print in grade 1 and 2, in big block letters, I want you to write the 5 equations out. So one of them I don't want you to double up, I'll tell you which one, and I'll tell you when to write them down. But to begin with, the first equation that they work with comes from the acceleration question. So I'll tell you what to write down. Don't write this down because you've already got it somewhere. It starts with this. Now, there's 4 unknowns here. There's an acceleration, there's a velocity 2, a velocity 1, and a time interval. So what happens if I want to find my velocity 2? I have to change the equation so that I can solve to get v2 by itself. So the first thing I need to do is do what?
Get rid of your time.
Get rid of my time. So I'm going to multiply the time up to the other side. So I'd end up with a delta t equals v2 minus v1. And then I need to isolate v2. So I want to get v2 by itself.
So add v1.
So I add v1. So the first equation that you're going to write down in nice big letters is v2 equals v1 plus a delta t. All right? All right, so there's equation 1. You write it down? Oh, no. That's what write this down in big block letters means. Shut up, Rob. Okay. The second equation, we don't use this equation often. I don't like the equation a whole lot because it lends to doing a lot of the questions using this equation, but it's not the right one. If you don't have an acceleration, all right, if this one stems from basically this guy here, velocity equals displacement over time. But velocity, if I'm trying to find out what displacement is equal to, it's equal to velocity times time. But what happens if you have 2 separate velocities?
You have to do v1 or v2 subtract v1 times time.
No, I don't use change here. That's the thing. That's why I don't care for this equation a lot. Is this equation is set up so that you actually find the velocity average times the time. So one way to write it is this way, or as they have in the book, v1 plus v2 divided by 2 times time. Now there's very few questions that we're going to use that equation for, but in a circumstance where we're given a couple velocities and we're given the time and we have to find the displacement, this is the equation that you would use for it.
So why divide by 2?
Because it's average velocity.
Oh,
So you're going to average the 2 velocities together.
Is that d average?
The average, yeah. Times time. Okay?
That is a long equation.
No. The next one is.
Oh, I didn't get that all down.
Now, start grading, boys. You're waiting around. Okay, the next one I'll set up for you. I don't need you to copy it down. I just want you to watch this, and then I'll get you to copy down the equation.
Is that delta t on the end of the equation?
Yes. All right. Okay. Now, this is a velocity time graph. Again, I don't need you to write this down. I'm just going to show you how we come about it. So on a velocity time graph, what does the slope of the line give us?
Acceleration.
It gives us acceleration. But if I want to calculate what the displacement is on this graph, how would I do that?
Use area.
I I use the area. So I need to find the area underneath the graph. In this case, I go down like this, over here, go down here, to like that. So basically I have to find the area of two things in this one. Okay? So I have V1 here and V2 here. Oh, sorry, that's not right. I have time 1 here. So there's my interval. There's time 1 and time 2, which gives me a time interval. I'd have V1 here, which is, sorry, V1's right here. Okay. So to find out, I would use my time interval here, and I'd times it by V1 right there, right? So that's the distance from here to here is V1. Agreed? So the area underneath here would be V1 times my change in time. Straightforward, right? Okay?
Yep.
All right. So using the same concept now, I need to find the area of this. Well, 1/2, my base, in this case, this is my base right here, which is change in time, right? And then this height, how do I calculate from here to here?
V2 subtract V1.
Not
Change in
distance.
velocity.
Change in velocity, V2 subtract V1, right? So this would technically be your change in your velocity. Agreed?
Yes.
So the areas of these, if I want to find the area underneath the graph, I would have V delta T plus 1/2 change in time times change in velocity. That's what I would have right there. Okay? But I'm going to change that velocity, this change in velocity. I've got acceleration equals change in velocity over change in time. We all agree? Yeah? So if I multiply that t up, my change in velocity would be equal to what here in this equation?
Acceleration times time.
Acceleration times time. So if I substitute this in for this, I'm going to have 1/2 t times a times t.
Yep.
Okay? Does everybody understand that? I'm going to put that in for this, and then I'm timesing that by that. All right? That leads us to our third, and probably the one that you are going to use the most is V delta t plus, actually, I've got this wrong here. This is V1 delta t
It says in the book that's
plus 1/2 a delta t squared.
nice.
Oops, right there. Okay, so I've got d, v1 delta t plus 1/2 at squared. There's my v1 delta t, there's the area there. 1/2 t times a times t gives me 1/2 a delta t squared. So that's the equation. All right? Austin,
Sorry, you're wanting to find the area of just the triangle or the whole thing?
the whole thing. The area underneath is the whole displacement.
Okay.
So to do that, you need both sections. You need the section in which there's a rectangle and the section in which there's a triangle. This shape is a trapezoid. Two lines parallel and the other two lines aren't parallel. Yes, Paige?
So that's only for a velocity time graph, right?
Well, we use this graph. I'm just showing you this. This means
Okay.
nothing to you right now. I'm just using the graph to show you how I get that equation.
Okay.
All right? Now, you don't need to show me that. I don't need to see that you can do that. What I need you to do is be able to apply that equation. Okay? The fourth equation is very similar to it, except it uses V2 and it has a subtract on it. Okay? delta D equals V2 delta T minus 1/2 A delta T squared. All right. And the very last equation, we use a lot as well. Is that one. V2 squared equals V1 squared plus 2AD. Now if you look at, there's 5 equations here. V2 squared. There's 5 equations there. Each of those 5 equations has 4 unknowns to it. You know, in order to solve for the missing one, you're going to need 3 of them to be known to you. So what we're going to get in practice of doing is looking at the information that's given to me and finding out which one I need, which piece I need, and then I match it up with the equation that has all 4 pieces of information. Now, if you look at the 5 here, this one is distinctly different from the other 4. How come? What?
Squared.
No.
Velocity.
No.
Hold on.
What is the glaring difference between the bottom one and the other 4? Yes. Yes.
It's not really glaring.
There's no time. This is the only one that doesn't deal with time. Time, 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 time. So when you're given the information in the question and there's no time given to you, that's the guy you're going to use. So that narrows down that equation quite often. If there's no time, you don't need to use any of the other 4, you need to use the one without the time. Okay? So the reason I said take out a blank piece of paper, make it big on your piece of paper, and have it beside you is because it makes the questions easier when you're looking at the equations themselves. All right? So I'm going to now look at a few example questions. And we actually, in fact, I'm going to look at the one we did yesterday. I want to look at question 4 from yesterday and 5 from yesterday. So open up to page 65. I'm going to show you how I suggest you set these up. 80% of you will do it this way and 20% won't. An arrow is shot straight up into the air at 40 meters per second. As it falls back to Earth, the acceleration due to gravity is 10 meters per second squared down. And the final velocity is 40 meters per second. How long does it take the arrow to come back to the ground? Okay, so we want to know the whole length of time of the trip in which the arrow goes up and comes back down. But I can't do the whole trip with the information that's given. So I need to know some other information. I need to know what happens at the top. That's important. I need to know that the acceleration is the same going up as it is going down. That's important. So I'm going to focus on the first part of this, from here to right here. So the first thing I'm going to write down is my V1, 40 meters per second. All right? What affects that arrow when it's going up? Gravity. And what did we say gravity is?
10 meters per second.
Yeah. We are now, after this question, we are now going to work on it. The actual value of gravity is 9.8 meters per second squared. You're going to use that. Okay? But for right now, for this question, we're just going to use 10 again. Now, because the arrow is going up, is it slowing down or speeding up? It's slowing down. So I'm going to put a negative value on my acceleration to show that it's slowing down. At the top, when the arrow hits the maximum height, what is its speed?
0.
It's 0 meters per second. And what is the question asking me to find?
How long does it take the air to come back to the
Which
ground?
is what? What's how long mean?
Total distance. Time.
Time. All right, take a look at your sheet right now. And on your sheet, which one of the equations has V2, V1, A, and time? The first one does. Now, we didn't have these when we did this. So, you needed to use acceleration equals V2 minus V1 over delta t. Change in velocity over change in time. I want to solve for time, so I just simply switch these two. So time is equal to change in velocity over my acceleration. In this case, my change in velocity is 0. Subtract 40 over negative 10. And you know whether or not you're going to get it right because the time has to be a positive value. Can't go backwards in time. So I have negative 40 over negative 10.
4 seconds.
Takes 4 seconds to go up. How long does it take to go down?
4 seconds.
So the total time it was in the air was
8 seconds.
8 seconds. That's how I want to see you approach the question. If you label your question with the unknown variables and the ones that you know, you'll get a mark on every question. If you can just simply read it and put that down on paper. From that point, I look at my equation sheet that's given to me, and I find out which one of those equations has those 4 variables in it. And then I solve using that. You may have to manipulate it. You may have to move some things around, but that's the way it works. All right? Anybody want to ask anything about that guy? Okay, open up to page 71 now. All right, work with me here. The first thing I suggest you do, and this is a good problem-solving hint, way to solve problems, whether it's math, physics, chemistry, whatever it is. First thing you do is try and read the question first. Read it, just read it to yourself, read the question, get a grasp of the question. So a ball rolls down a hill with a constant acceleration of 2 meters per second squared. The ball starts from rest. What is its velocity at the end of 4 seconds, and how far did the ball move? So what do we get an understanding of? You've got a ball starting at the top of a hill. It rolls down a hill. It's accelerating. Should, right? Should be going faster as it goes downhill, correct?
Yeah.
Gives you a time, gives you an acceleration, and it asks what is its velocity at the end, so I'm looking for V2. So now that I've read the question, I have a bit of an understanding, I go back and I pick out the information that's given. Somebody tell me what's the first piece of information that's given in the question.
2 meters per second.
Correct? Acceleration is what?
2 meters per second squared.
So the first thing I write down is A equals 2 meters per second squared. Perfect. Now I keep reading. If the ball starts from rest, what is its velocity at the end of 4 seconds? What's the next piece of information that's given?
Rest.
What's that?
Starts from a rest.
Which is what?
0.
Yeah. So what variable would I be using there?
V1.
Yeah, well done. That's the hard one. That's the one nobody seems to pick up. You skip it over. One of the things that you'll know, anything starts from rest, V1, 0, that's easy, right? If I'm dropping something, what's the initial velocity?
0.
It's not moving, right? So those are the two instances where you're going to get that often, where V1 is actually 0. Okay, so that's a great pickup. Go ahead.
V1 is 0 every time?
No, not every time, but if it starts from rest, though,
Then it's 0.
then it's 0, right? Or you're dropping it, it's starting at 0. Okay, so then what's the next piece of information? Yeah, what is it, Casey?
4 seconds.
Times 4 seconds, and then what's the question asking? Because I've already got 3 pieces. What's the question asking for?
What's the velocity?
V2. All right. Which of your equations? Which of your equations has that information in it. First one. Okay. What does two has distance in it, doesn't it?
Yeah.
Right? So it can't be that guy because they don't have distance. Make sense?
But then on the set, it said for B, it says how far did the ball move?
So we're not there yet, Austin. We're gonna fall. we're
Yeah,
gonna
that's a
finish A.
different question.
Okay, so we're gonna use that first equation, right? First equation, B2 equals
B1.
plus A delta T. You put that down. You got all that in the, you got a mark.
Yeah.
All right, that gets you a mark right there. Now, plug in your numbers. Most of you will like that better. What's the velocity after 4 seconds? 8 meters per second. Okay?
So for your acceleration, you don't put meters per second squared.
Well, I just said that. Put your numbers in. It's easier without variables right now. Yes, you should have your variables for everything. But for right now,
So that 8 meters per second should have.
it has to, yes.
Yeah.
I need to see that that's meters per second. Okay? All right, the second part says, how far did the ball move? So now what am I looking for?
This.
I'm looking for distance. Now, in theory, you could use the V2 that you found in the first part. But what if I got it wrong?
Oh, that's an issue.
Then I'm not going to get the B part right. Correct? So what I'm going to do is I'm going to do the question as if I don't have V2 there. Now which equation?
Third one.
Deals with A, B1, T, and D. Okay?
Third one.
The third one does. The third one does. That's the guy you're going to use a lot. D equals B1 delta T plus 1/2 A delta T squared. Okay? I said every time I turn my back, you look at those two guys. Can you not do that, please?
Try. I'm sorry, yeah, I will.
You're going to go over there for the rest of the year if you continue it.
I'm sorry.
Okay? V1 delta T. What's my V1?
0 meters per second.
0. So if I take 0 times T, what do I get? 0, right? So I'll just put a big 0 there. Then I got 1/2, 2, and how many seconds? 4 squared. How many meters did it go? 16 meters. Okay? This is your introduction into physics and solving questions that are pertaining to kinematics and using equations. Those 5 equations you're going to use a lot for the next 2 years. Those 5 we come back to, we come back to, we come back to. We always end up using these 5 equations, a pile. Because we start studying vectors and then we use those equations to tell us how to draw pictures. So you've got to get them down now if you want to be successful as you go through.
So we do not get a formula sheet.
Yes, you get a formula.
Oh, that is okay.
Okay? But it's made for you. You don't get to write anything on it. Let's look at the second equation, or the second question here. Now, electron is accelerated uniformly from rest to a velocity of 2 times 10 to the 7 meters per second. The electron traveled 0.1 meters. While it was being accelerated, what was its acceleration? Okay, so I read the question. What's the first piece of information that is given in this question?
B1 is S, so 0.
Very good. What's the second part? B2? Was it 2 times 10 to the 7?
Yeah.
I also want my units on this guy too. I want my units when I'm listening in here. And then what else did it give us? What was the distance? 0 meters. And what did you ask to find?
Acceleration.
All right, so look at your 5 equations. Which of the 5 equations
The last
The
one?
last one.
The last one does. Because what is this guy missing right now?
Time.
I'm missing time. So now I have this. This is what I said. Those of you that may struggle with algebra a bit, this is where the struggles might come in. It shouldn't, but it may. All right, I need to isolate for A here. So what's the first thing we want to do to isolate for A? Very good, Rex. V2 squared minus V1 squared equals 2AD. Now how do I get A by itself?
Multiplied by 2.
V2 squared minus V1 squared over 2D. All right, and then we just fill in our information now. A equals 2 times 10 to the 7 squared minus 0 squared over 2 times 0.1. Okay, here's where the calculator work comes in. Can you punch that into your calculator and get the correct answer?
I don't think
The bottom you have to remember should be in brackets. Anytime you have an application on the bottom or a function on the bottom, you need to have it in brackets.
Yeah.
The
And then
seven-
is that a multiply 0 to?
No, it's subtract 0. So you don't need that. 2 times 7, 2 times 10 to the 7, so 2 exponent 7 squared, divided by, and then you got a bracket, 2 times 0.1, close the bracket. Yeah, go ahead.
I got 4 times 10 to the power of 15.
That's what I got too.
4 times 10 to the power of 14. And that would be meters per second squared. And
It's a lot of zeros.
is it 14 or 15? The book has 15.
Oh,
I have 2 to the 15.
That's what I have.
Also, I got 2 is 2 to the power.
Okay.
I got the same as you guys over there.
It is 2 times 10 to the power of 15. So
Why-
let's
how
have a
did I
look.
get that so wrong?
You still got it on your calculator? I can look at it?
2 times, so would that be,
My answer's on the calculator.
wait,
yeah.
2 times 10 to the power of 15, so would that be 1?
What? Oh.
Is that, what's that? I'm
Okay.
zeros, it can't be. Is that 8 zeros?
Okay, I'm just gonna try it again and see what I get.
I don't know, I got 1 word.
Oh, and now I got
100 million.
Now I got 2 times 10 to 15.
Yes. I don't know. Well,
Actually, yeah, I got to the power of 7.
Yeah, I got 2 to the power of 15 now. 2 times 10 to the power of 15.
yeah,
I'm too
I forgot to square the 2 and bring back and then.
Okay. This is the problem I have. I need you to
Oh,
listen
that
closely.
N.
You need to double
Well, I
this
need
up.
to, I knew that.
By going times 10 E. E is 10 to the power of 7. Don't put the 10 in there,
I'm
because
cheesy
then
on this. I'm
that's how it
bad.
changes the question for you. So, let's go.
This class is not gonna be good.
I said something more preparation. Backward.
So what,
What is in first?
you basically were redundant on that. You put times 10 to the power and then times 10 to the power again, so that's, you were off by 100, right? You're 100 too much, times 10 is 17, so that's what happens there. Okay, how are we doing?
There's one that I'm confused, but I'll get it when I do questions.
That whole thing goes on the right side there. It's good.
That's just the changing of the equation?
Yeah, that's.
Okay,
The algebra is gonna be a little tricky, so.
it's gonna get a little trickier, yeah, so. Okay, that's basically all I want you to look at right now. You had a booklet of graphic questions I gave you yesterday. Yeah, you can finish that up today. If you happen to get done that, you can look at page 73 and 74. There's 6 questions, but if you just get to the graphing, then that's fine today as well. Okay, so that's what I need you to work on right now.
Uh-huh.